Hello students, in this video I'll solve some problems related to limits of a trigonometric functions. In that, the first one is problems based on limit theta tending to 0 sin theta by theta equal to 1 formula. We already derived this formula, right? Limit theta tending to 0 sin theta by theta value will be always equal to 1. Look at the first question. Limit extending to 0 sin ax divided by bx is there. We need to solve this using this formula only. If theta is in the numerator means divided by we want theta itself. So limit extending to 0 sin ax is there, right? I can write sin ax. I want by ax to balance the equation multiplying by ax, and the denominator bx will remain the same. Now see, by the formula sin ax by ax value will be equal to 1. So I can get limit extending to 0 1 into ax divided by bx. Again x get cancels, so that limit extending to 0 of a by b is there. We already have the formula, right? Limit of a constant function is always equal to that constant itself, so that limit extending to 0 a by b, answer will be equal to a by b. Look at the second question. Sin ax divided by sin bx is there. So again I need to convert this formula as sin ax by ax and sin bx by bx, so that limit extending to 0 sin ax, I want by ax into ax to balance the equation multiplying ax, divided by, see, sin bx is there. Sin bx, to apply the formula I want by bx in the denominator. See, theta by theta to balance the equation multiplying by bx. See here, x tending to 0 is there. That implies ax also tends to 0 and bx also tends to 0. So it is not a problem, okay? As x tending to 0, your ax will tends to 0 and bx also tends to 0. So simply we can write it as x tending to 0. Now see, in the next step, it's equal to sin ax by x outside limit extending to 0 is there. So that 1 into ax divided by this much value also equal to 1 into bx. So outside limit extending to 0 is there. So it's equal to limit extending to 0. Before applying the limits, you need to simplify. So x get cancels. Again you will get answer as a by b. Limit of a constant, it's equal to the same constant. So answer is again equal to a by b. Next see, limit extending to 0 ax plus x cos x divided by b sin x is there. So again it's a trigonometric, not on this formula. We need to solve using trigonometric formulas only. So that limit extending to 0 a into x plus x into cos x divided by b sin x is there. So first substitute 0 directly. You can get, see, a into 0 is 0, 0 into cos x is 0 by b into sin 0 is 0. So it is a 0 by 0 form. So first we need to simplify this one. For that reason I can rewrite it as, see, limit extending to 0. Here see, x is there, right? Take x outside. So what is remaining? A plus cos x divided by b into sin x is there. So that we can write it as b sin x. Now see, sin x is there. To apply limit theta tending to 0 or extending to 0, sin x by x equal to 1 form. Here I will divide by x into x. So that the next step, see, limit extending to 0 x into a plus cos x divided by b into, what is sin x by x as extending to 0, its value is 1 into x. Now see, x get cancels. So remaining function is limit extending to 0 a plus cos x divided by b is there. So it's equal to, take x equal to 0, so that a plus cos 0 divided by b, it's equal to a plus cos 0 is value is equal to 1, right? So that you will get a plus 1 divided by b. So answer is a plus 1 divided by b. See the next question, limit extending to 0, sin ax plus bx divided by ax plus sin bx. You can clearly observe as x tending to 0, if you substitute x equal to 0, see, first one will be 0, second will be 0, b into 0 is 0, 0 by, here also a into 0 is 0, sine of b 0, that is sine 0, so that again 0 by 0 form. So we can't substitute x equal to 0 directly. So simplify this one, it's equal to limit extending to 0, keeping it outside. Then see sin ax is there. To get the required answer, divided by ax into ax. Because sin theta by theta, then only we can substitute it as 1 plus what is remaining, numerator bx is remaining. Divided by, again see ax no change, plus sin bx. To apply the formula, I want bx in the denominator, theta by theta or x by x. So bx by bx, to balance the equation, multiplied by bx. So it's equal to limit extending to 0 will remain same. See sin ax by ax, outside limit is there, right? So its value is 1 into ax plus bx divided by, here see again this much value bx by bx, its value is 1, so that ax plus 1 into bx. In the next step, see, it's equal to limit extending to 0. What is the common term? Ax bx, x is the common term, right? So that a plus b divided by, here see x and x is there, x common term, so that a plus b is remaining. Before applying the limit, cancel x and x, so that limit extending to 0, a plus b by a plus b, so that a plus b get cancels, limit extending to 0 of 1, limit of a constant function 1, its value again it's equal to 1 itself. See, next question is limit extending to 0, sin 4x by sin 2x. If you substitute x equal to 0, you will get sin 0 by sin 0, it's equal to 0 by 0 form itself. So we need to simplify this one. So see, limit extending to 0, sin 4x, to apply the formula I want by 4x, balance the equation into 4x. Our formula is limit extending to 0, sin x by x must is equal to 1, right? So to get that form, dividing by 4x to balance into 4x, divided by, here also same thing, see, sin 2x by x, that is by 2x, balance this one into 2x. So in the next step, see, it's equal to limit extending to 0, sin x by x, this much value is 1, this much value also equal to 1, right? So that we will get 4x by 2x, x get cancels, so that limit extending to 0, 4 by 2, it's equal to 2. Limit of a constant, it's equal to the same constant, so answer is equal to 2. Limit extending to 0, tan x by x, we need to evaluate the value of limit extending to 0 tan x by x. So to solve this one, see, limit extending to 0, what is tan x? Sin x divided by cos x, right? Tan x into x, or divided by x is there, this x will move to the denominator, right? So that I can rewrite it as limit extending to 0, sin x by x into cos x. In the next step, see, denominator multiplication is there, so that we can split into two parts. It's equal to limit extending to 0. See, first one is sin x by x into 1 divided by cos x is in the denominator. Now apply the limit. We already know, right? Standard result, limit extending to 0, sin x by x value equal to 1. So that here see sin x by x value is equal to 1. So 1 into 1 by cos x value is 0. It's equal to 1 into 1 by what is cos 0? Cos 0 value is 1, right? So 1 into 1 by 1. So it's equal to 1 into 1, answer equal to 1. So the result is limit extending to 0 tan x by x is equal to 1. It's of the other trigonometric functions. Here we need to use some trigonometric formulas, or after simplification you may get again limit extending to 0 sin x by x form. So the first question, see, limit extending to 0 cos x by pi minus x. First substitute the limit directly. See, limit extending to 0 cos x by pi minus x, that is a given question, it's equal to cos 0 by pi minus x is 0. So that cos 0 is 1 by pi minus 0 is pi. So that directly we can get the answer, it's equal to 1 by pi. But look at the second question, that is limit extending to 0 cos 2x minus 1 by cos x minus 1. If you substitute x is equal to 0, what you will get? See, cos of 0 minus 1, again cos x is cos 0 minus 1, it's equal to cos 0 is 1 minus 1 by 1 minus 1. See, it is 0 by 0 form. We can't substitute limit directly. For that reason we need to simplify this one. So we need to solve this one. For that one, see, we have the formula cos 2x is equal to 2 cos square x minus 1. Okay, so I can rewrite it as a limit extending to 0 cos 2x is substituted as 2 cos square x minus 1, and see, one more minus that is given in the question itself, by cos x minus 1 is there. Next step, see, limit extending to 0 2 cos square x minus 1, it's equal to minus 2 divided by cos x minus 1 is there. Next step, say limit extending to 0. Here 2 is there, here 2 is there, so take 2 outside. So that cos square x minus 1 divided by cos x minus 1 is there. Next step, see, it's equal to limit extending to 0 2 into, I can rewrite it as cos square x minus 1 square, right? 1 is 1 square divided by cos x minus 1. Now see, numerator is of the form a square minus b square. A square minus b square equal to a plus b into a minus b. So that I can rewrite it as a limit extending to 0 2 into cos square x minus 1 square is cos x plus 1 into cos x minus 1 divided by cos x minus 1. Now see, cos x minus 1, cos x minus 1 get cancels. Next, write the remaining terms. It's equal to limit extending to 0 2 into cos x plus 1. Substitute the limits. It's equal to 2 into cos x value, I need to take it as 0 plus 1. So it's equal to 2 into cos 0 is 1 plus 1. So that 2 into 2, it's equal to 4. So 4 will be the required answer. Next question is limit extending to 0 x into secant x. See, it's equal to limit extending to 0 x into, what is secant x? Secant x is 1 divided by cos x, right? So it's equal to limit extending to 0 x into 1 by, again I'll rewrite that one, cos x, take the limits 0 into 1 by cos 0. So equal to 0 into 1 by cos 0 value is 1. 0 into 1, answer equal to 0. It is a direct substitution, or you can directly take values, because it is not 0 by 0 form, right? X 0 into secant 0. Secant 0, what is secant 0? 1, right? 0 into 1. Directly you will get it as equal to 0, or you can simplify like this also. The next problem, see, limit extending to 0 cosec x minus cot x. You can substitute limit directly, otherwise first solve, then simplify, then substitute the limits. So we'll take limit extending to 0 cosec x is nothing but 1 by sin x minus cot x is sin x divided by cos x, right? And the cot x is cos x divided by sin x. So that we can rewrite it as a limit extending to 0, 1 minus cos x by sin x. Okay, because here denominator is same, so that we can add the numerator directly. Again, if you substitute limit directly, see what you will get: 1 minus cos 0 1, 1 minus 1, 0 by 0 form. So we need to use trigonometric identities. Just recall the formulas. See, first we have cos 2x is equal to 2 cos square x minus 1. Another one is cos 2x is equal to 1 minus 2 sine square x. And sine 2x is equal to 2 sine x into cos x. By this formula, see, I want 1 minus cos x. So I will take this formula. Cos 2x equal to 1 minus 2 sine square x is there. See, I want 1 minus cos x. For that one, first I will write 1 minus cos 2x. 1 minus cos 2x, taking cos 2x to the right hand side. Then minus 2 sine square will come to the left hand side. It will become plus 2 sine square x. Okay, this is a one formula. And see, sine 2x equal to, we already have 2 sine x into cos x. So we can rewrite it as 1 minus cos 2x is equal to 2 sine square x. So what will be 1 minus cos x? In place of 2x I am taking x, that is x is replaced by x by 2, 2 get cancelled, so that I will get x. So here I will get 2 sine square x is replaced by x by 2. Take x is equal to x by 2. Now see, again sine 2x is equal to 2 sine x into cos x is there. What will be sine x then? Sine x is equal to 2 sine x by 2 into cos x by 2. Again taking x is equal to x by 2, so that here 2 get cancelled, so we will get only x, but right hand side x will replaced by x by 2 and x by 2. So now substitute here. By these two formulas I can rewrite it as it's equal to 1 minus cos x is 2 sine square x by 2 divided by, here see, sin x is 2 sine x by 2 into cos x by 2. So 2 get cancelled, sine square x by 2 sine x by 2, 1 sine x by 2 get cancelled. So the remaining sum is equal to sine x by 2 divided by cos x by 2. So outside limit is there, limit extending to 0 is there. So that it's equal to limit extending to 0, limit extending to 0, sin x by 2 by cos x by 2 tan x by 2. So that if you substitute the values as 0, you will get tan 0. Tan 0 value is equal to 0. So again the limit value will be equal to 0.